Hello, today I'm going to show you how to make a Nintendo Entertainment Raspberry Pi Media Center. To start off with, I'm going to show you the parts that you'll need. So obviously you're going to need an NES. I got this case off of eBay. It cost me about $20, and you'll notice that it's a little damaged, but I mean, we're gonna make it into a media center, so it's cool. I have two NES controllers at the top. Over here, I have two adapters, one of which I've already started cutting up, which we'll get into. I have a Raspberry Pi 3. I got it in a pack that came with, an HDMI cable and an SD micro card. So I really recommend going that route. It also came with like a power supply, which is pretty invaluable. Also, in order to power it, we're going to want a USB micro kind of extension cord. This one, I believe, is probably 10 centimeters. It's pretty short. And basically the shorter the better, because essentially what we'll do is we'll have this part in the back of the NES, and we'll have this plugged into the Pi. So if there's too much of a length, if this wire is too long, then the Raspberry Pi won't get all of the power that it should be getting. But anyway, we'll talk about that more. I have a Mosberry switch. This is the USB micro version, very nifty. I have a mountable HDMI cable, so we will mount this to the back of the NES and plug the other side into the Raspberry Pi. And then I have two USB 2 mountable cables here. So essentially what we're going to be doing is putting these in the back so that people can add USB to it, whether they want to have a FLIRC or they want to have a Bluetooth keyboard. They can do whatever they want. Two of those ports, however, are going to be used by these NES adapters. They're pretty useful. I really like them. They have a fast response rate, and they make being able to play a Nintendo Entertainment System game on the emulated console very, very useful. So you can see the buttons work. There's nothing inside of it, which I'll get to in a second, but that is basically the materials that you need. Here we have the inside of the Nintendo. Essentially what we're going to need here is just the original power button and reset button. We're going to be using this circuit. Essentially, we're going to be connecting this to the Pi so that it uses the original functional power buttons. Very cool. On the other side, you'll see that there are the controller wires. We're not actually going to be using these. That's why we have the USB versions. Although, if you wanted to, you could solder these directly into the Pi, but I don't want to because I'm kind of lazy. And this is for the power. It goes underneath. The first thing that we're going to want to do is cut the casing off of the USB NES adapters. The reason why is because the inside is the correct height and width for it to fit inside of the NES, but with the casing it's just a little too fat. You can kind of see here there's a little bit of a comparison. They make it really useful. It's kind of hard to see in this light, but you have the inner part that fits in the NES, and what we want to do is use a razor to cut this outer casing off. We also need to be careful about cutting the wires back here. You don't want to cut it too deep, otherwise you're going to sever the connection and it's going to be useless. So it's going to get started. What I usually do is I go at an angle. It's pretty solid, but if you go at an angle and cut it kind of like you would like an orange peel, it works really well. So I'm going to cut that. And as you can see, they have both been cut. It doesn't have to be absolutely perfect. You'll see that there's still a little bit of the original casing here, but so long as the length and the width is fine, you'll see that the casing isn't around it, then we're good. Next, we need to be able to put them inside of the NES itself. In order to do so, we'll first unscrew these bottom screws. Be careful not to misplace your screws. Then we'll flip it over, and you'll see that this front panel actually just slides off. Hooks on at the top, and it comes off. So now we have, that's a little hard to see again, I apologize about that. We have the original adapters that we want to replace with the USB adapters. So we'll just pull these out. They've already been unplugged from the main machine. So now we have an open port. Unfortunately, you'll see here that the original adapters come with a bit of an angle here. That's so you couldn't take something rectangular and fit it inside. So what we're going to need to do in order to get this to fit is cut the angle off of here. And then it'll be a tight fit, but it will fit. We'll be doing that with a Dremel. Once you've finished dremeling, it should be perfectly rectangular. It'll fit, although what we also want to do is cut these 3 poles. The thing is, we don't need really any of these main screw mounts. So what we're going to do is we're going to use the Dremel to cut these 3 away, allowing us to fit the USB adapter that far in. So as you can see, I Dremeled them away. I didn't do a perfect job dremeling, and the reason why is that it's on the inside. Same with here, it's going to be covered by this faceplate, so even though it's imperfect, it doesn't really matter. So basically I've ensured that the cables will fit. They'll go in through here, and now I'm going to put them in. Also note that the NES, this is the way that the ports show. This is upside down. This is right side up. Once the new adapters are in, we're just going to cover it with the faceplate. Perfection. Now's the fun part. We get to decide exactly how we want to set up the inside. What I've decided to do is put the 2 USB kind of in the corner, and then I will have, let's see if I can turn the light on. Going to do the 2 USB in the corner, and then I'm going to have the HDMI sort of to the left of it with the power directly on top of that. So I know that I have a lot of room to work with, and I could spread them out, but I really like having all of my plugins kind of centralized, and my ultimate plan is to put the Raspberry Pi on this hook. So this will give it enough room to kind of not all get jumbled into one section of the Pi over here. As you can see, I kind of outlined in Sharpie roughly where I'm going to cut. These 2 on the side don't matter all that much, just because I can move them around. They're very flexible. Same thing with the HDMI over here on the side. I can kind of do whatever I want so long as I get it started and use a lot of patience. You want to make sure when you're making these cuts, you're not making them too big. So what I usually do is as I'm I'm cutting it, I'll plug in what would go there, right? Because that means that the female section would be able to receive it. So I'm going to cut the HDMI, and then I'm going to cut the 2 USB holes on the right side. As you can see, I have finished drilling my holes. I have one for the HDMI port, one for the USB micro for the power, and then 2 for standard USB 2. One of the things that I did was kind of trim the edge off of here. Here's kind of a better angle. The plastic, move that out of the way. The plastic used to go, or the rubber used to go from the tip flush with the metal. And so what I did was I kind of cut that away so that a little bit of the metal is able to go inside of the case. You can kind of see I did the same thing with the USB. It is partially inside of the hole. Instead of just being either fully outside or fully inside. This helps with durability. Now that I have it that way, it's going to take a lot of force for this to come out. And the thing is, we want to be able to plug in all of the external things into these wires without them popping off on the outside. You can see this isn't glued or anything. It's there we go. It came out. But that'll make it very, very durable. That's also one of the reasons why you don't want to cut too much in any given direction. Obviously, it doesn't look perfect, and it's gonna be on the backside anyway, so it doesn't matter. But the way that I designed this, it's very flush with the ports, so that it's very, very strong. Again, the HDMI itself isn't glued in yet. And neither is the USB micro. So the next step is going to be getting rid of, or rather cleaning up kind of the plastic dust that's accumulated. And then when you're done with that, use some epoxy to glue everything in. I'm just going to use this really super strong epoxy. It's totally overkill, but I want these things to never move. And so by essentially blasting it with the strongest glue we have, we'll make sure that they stay in place. I also wanted to give a disclaimer. You really want to make sure that you verified the cables before you're gluing them. Gluing them makes them fairly permanent. I mean, if you really wanted to take them out, you could use some sort of solvent to get rid of the glue, but we don't want to get that far. We want to make sure that the USBs work, we want to make sure that the USB micro works, and that the HDMI works. So I have verified all of it works, and I'm going to epoxy it now. So now I've finished setting the ports in there with the epoxy. I'm going to let it dry for about 24 hours, 24 or 48. I want that epoxy to get very, very hard so that I can mess with the case later and it won't fall apart. So for now, I'm going to take a well-deserved break. Okay, so now that we've finished cutting all of the holes and inserting the cables that we need, we've also replaced the original controllers with these USB controller adapters. The last thing we need to do is wire up the power buttons so that the original power buttons work for controlling the Raspberry Pi. So after you have detached the power buttons, they have 2 little screws, one on the left side and one on the right. Very easy to get out. You just take it out. You actually need to make a cut with your Dremel. I'll turn this over so you can see. Here at the top, what you want to do is sever that connection by dremeling just a little bit right here, just a notch. But that way, the light will be wired to the Pi and not via the original power that we would have gotten. More on that in a minute. We are going to start the connection by cutting the tip off of the original power buttons. That way we can wire up the wires to our extra circuit. After the end connector has been cut, you're going to want to strip the wire off of the ends of, or strip the casing off the ends of the wires. We're not actually going to be using the kind of tan white-ish cable, so don't worry about cutting that one. Just the brown, red, orange, and yellow ones. So as you can see, I've done a little bit of soldering. I soldered a GPIO connector straight to the left side, and then on the right side I have the resistor hooked up to another male end of a GPIO pin. I'm going to connect both of those ends to the Pi. So as you can see, I've finished doing the soldering. Starting from the top, you'll see the SW. That one is for the brown wire. Next to that on the left is the red wire. Below that, let's see if I can get a better focus. No, go back. The 3ND/RTS minus is the orange wire, and then the RST plus is the yellow wire. So from here, I'm going to plug this into the Raspberry Pi and get everything put together for you. One thing I forgot to mention is that this pole will actually need to be cut. When you try to plug in the power buttons, because we've soldered in this general area, it'll hit this. So you need to remove this pole before you put everything together. And once everything is put together, we have the completed project. I will show what it looks like when it's turned on, but we have the original power and reset buttons connected to the Pi via this cable and that one. We also have those buttons connected to our power switch here in the back. We have the power switch connected to electricity via the power wire here, HDMI out, HDMI in, and two USBs on the back alongside the two USB to NES controllers in the front. So let us test it. As you can see here, I now have the NES all set up. I have the power in the back along with the HDMI, and I have a FLIRC, which is an infrared to keyboard converter, oddly enough. It allows us to use universal remotes. Very nice. So anyway, I figured I would show you what it looks like when it's turned on. So push the power button. You'll see the light turns on instantly. This is the latest version of LibreElec. It is 8.0.2 with Kodi, and it pops up with the main screen. I don't have any files on here yet, so I apologize not being able to show off, videos. But as you can see, I'm actually able to control it with the NES controller, which is very, very cool. It's such an amazing function. The latest version of LibreElec will do that. Go to add-ons. I also have RetroPie over here. I'll hit that. See, it's launching RetroPie. Little beep 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 means it's done, or it's executing. This particular SD micro has both LibreElec and RetroPie built in. I really prefer having the dual boot as opposed to just a single and having to hot swap them or swapping them out. RetroPie. Emulation station. This version also doesn't have anything, so I don't have any ROMs to show you, but it does work. I'm able to go into RetroPie, I can configure it, I can go back into Kodi and launch that, and it will take me back to Kodi. Open up LibreElec again. Cool. And so now I've shown you that you can switch between the two operating systems. I did a tutorial that on my blog. Check it out. It's awesome. And finally, I'm going to show you what happens when you push the power button to turn it off. Actually, I'm going to try reset first. So when I hit reset, you'll see the screen went blank, and it will load back into the operating system that you were just in. It's kind of like a hard reset, so it's not terribly great for the Pi, so it's not something that I do regularly. We have Cody up and running again. Now I'll show you what happens when you push the power off. So unlike a traditional Nintendo, you'll see that the LED stays on, and there's actually information on the TV. What the power button does is it tells the Pi run a shutdown script. So takes about 5 or 6 seconds, but you'll see the TV turned off, and once the script is finished, the power or the LED will turn off too. Anyway, I hope you like my tutorial on how to build an NES with a Raspberry Pi inside. Hit the comments. Let me know what your thoughts are, if you have any questions, if you like to do it yourself. Thank you.